Hello, today's lesson is on reflections, section 9.1 in your book. The first vocabulary word that you have for this lesson is called isometry. An isometry is a transformation that does not change size or shape. Okay, so it stays the same size and the same shape no matter what you do to it. That's an isometry. A reflection, which is the lesson for today, is a transformation that flips the figure across a line. So this picture right here is a picture of a reflection. It's flipped across the line. Each endpoint is equally distant from this line. This is a counterexample. This is an example of something that is not a reflection. Because do you notice that this endpoint, which relates to this endpoint, are not on the same, not equally distant away from this line. This figure over here shows you that each point or endpoint of the figure is going to be exactly the same distance to the line of reflection. So this segment is going to be congruent to this segment. This segment is going to be congruent to this segment. And this segment is going to be congruent to this segment. So A to A prime. A figure is normally used uppercase alphabetical letters like A, B, C. That would be the pre-image, the original figure. And then the image will be the figure after it has had a transformation. So in this case, it was a reflection. And when you go from a pre-image to the image, you're going to want to label your vertices with the little prime symbol. That's a little tick mark above the letters. So that's A prime, B prime, C prime. The line of reflection is the perpendicular bisector of each segment joining a point to its image. So each segment here is going to be congruent to the segment that corresponds to it on the other side. It is also going to be perpendicular. Perpendicular means that it forms a right angle. So this is the perfectly straight line from the line of reflection to the endpoint, perfectly straight line from the line of reflection to the endpoint. And that makes this line a perpendicular, and it cuts it in half, so it's a perpendicular bisector. It's perpendicular and it bisects. Perpendicular means it intersects to form right angles. So two lines are perpendicular if they form a right angle. That's our right angle symbol. Now, when we're talking about reflections, there are a couple different things that happen when you reflect about in the coordinate plane. When you reflect on the x-axis, when you reflect on the y-axis, and then if you reflect on that line, remember in Algebra 1 of the line that is y equals x. When you reflect upon the x-axis, you're basically putting the point on the other side of the x-axis equally distant from the axis. So when you do put that point over here, your left and right position doesn't change. So the x coordinate doesn't change. So if you're mapping a coordinate x, it maps to itself. It maps to x. It stays to be the same coordinate. Now, if you're going to map your y maps to the opposite, because in this quadrant, y is negative. Up here it was positive, so it's the opposite. So the cheat or the mapping from the across the x-axis, the y is opposite and the x stays the same. When you're doing the y-axis, you notice left and right moves and up and down stays the same. So the x is opposite and the y maps to itself. Because it's across the y-axis, x is opposite. Across the x-axis, y is opposite. And then remember the line y equals x. That's the line that's 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2. That's that line that goes straight through the middle of the axis, through the origin, through the middle of the coordinate plane. That's called y equals x. When you have a reflection about the line y equals x, what happens is the x coordinate maps to the y coordinate and the y coordinate maps to the x coordinate. So what happens is the two coordinates flip. So if I were to put in values for these points, if I called this point 1, 3, and I called this point 1, 3, and I called this point 1, 3, if 1 is x and 3 is y, when you reflect across the x-axis, the new coordinate will be 1, negative 3. The y changes. When you reflect across the y-axis, the new point will be negative 1, 3. The x changes. When you reflect across the line y equals x, they flip. It becomes 3, 1. So these are the three things that happen when you reflect across the y, the x, the y, and the line y equals x. Now, if it's just a regular old point, you want to reflect triangle FGH with vertices negative 1, 4, G is 2, 4, and H is 4, 1. You want to reflect across the x-axis. Remember, our F coordinate is negative 1, 4. And remember, across the x-axis, x stays the same and y changes. So negative 1 stays the same and y is opposite. So F coordinate, negative 1, 4, maps to F prime, negative 1, negative 4. The G coordinate maps to G prime down here. X stays the same and y is opposite. So it's 2, negative 4. And then x stays the same and y is opposite. So H coordinate 4, 1 maps to H prime coordinate 4, negative 1. Okay, so now let's talk about the horizontal and vertical lines. Horizontal and vertical lines are lines, the y equals something line and the x equals something line. So the horizontal line is y equals whatever the y-intercept is, and the vertical line equals, x equals whatever the x-intercept is. So B is the y-intercept, and A is the x-intercept. Okay, so A is the x-intercept and B is the y-intercept. So if you wanted to talk about a horizontal line, remember a horizontal line is that line that goes left to right, the horizon. The name of this line, horizontal line, is whatever this coordinate is, 0, 3. The name of this line would be y equals 3. So it's the y line. And a vertical line, if I went vertical and I named this point 3, 0, this line is x equals 3. So when we're talking about horizontal lines, the equation of a horizontal line is y equals whatever the y-intercept is. The equation of a vertical line is x equals whatever the x-intercept is. So this is A0 and this is 0, B, because B is the y-intercept, A is the x-intercept. That's all for today. See you tomorrow.